Hi, welcome back. So in this short video we're going to look at a use case that's come up with a few customers. So these customers are already running Contrail enabled data centers on premise. So they could be OpenStack, Kubernetes, OpenShift, VMware for example. Customers running Contrail as an SDN are used to being able to stretch VRFs, so stretch tenant networks across data centers just by tagging the networks in the SDN with a root target. But as ever, customers are marching out towards public cloud. So there's a tendency nowadays to have on-premise applications across their data centers and then to run public cloud native services. So what they're asking is, can we extend the level of automation that we're using within the DCs and between the DCs all the way out to native services in AWS, for example. So in past videos I've shown running Contrail SDNs in AWS, but this video we're looking at native services, so there's no Contrail up here. There is Contrail down in the data centers, and we're going to use VMXs deployed in Cloudformation and configured in user data to stretch the SDN networks from the on-prem all the way out to virtualized bare metal networks, which then include native AWS services in Amazon. So as this use case is perhaps a little bit involved if you're coming at it cold, I thought a diagram might help explain. So here I'm showing 3 data centers, DC1, DC2, DC3. In each data center I've got a couple of virtual networks, red, blue, and connected to those networks I've got some VMs or Kubernetes pods. But what's important is each of these data centers is Contrail enabled. So it's going to have a Contrail SDN controller in it, and these networks are going to sit in overlay within those SDNs. And Contrail runs the same way regardless of who's orchestrating. So from Contrail's point of view, it has virtual networks and it's unopinionated on whether those networks sit inside OpenStack or VMware or Kubernetes or OpenShift. So let's propose that you've been deploying these networks for some time and you have hundreds, maybe thousands running across your data centers. And you've been merely stretching the tenants, the blue tenant or the red tenants, across your DCs and across networks within the DC, just by setting root targets in Contrail's SDN. But now predictably your developers are pushing out into public cloud. They've already got networks within AWS, and within these networks they're running AWS services. So here let's consider that they're running EC2 instances. Perhaps these have a database or some special software running up in AWS. Now if your developers are already deploying into AWS, then they or you are going to have built some infrastructure for that. And a typical type of infrastructure between an on-prem and AWS would be VPN gateways. These terminate natively in the VPCs in AWS, a direct connect gateway, or a transit gateway. So 3 different ways to achieve the same thing. In essence, to create a VLAN that transports traffic from your on-prem up into AWS. So we could plumb these networks. We could use gateways in the data centers, and we could plumb these networks from overlay to underlay across your WAN, through your IPX, over IPsec or over a VLAN for direct connect or a transit gateway to a VPC gateway, and then we could plumb them out. It's going to work, but you're obviously going to lose a lot of things, right? Automation, multi-tenancy, the level of tenant-based security that you have in your SDN is going to get lost. So instead of doing that, what we propose here is the following. We deploy a VMX, so a virtual MX, into AWS. We just use a one-click stack for that. That virtual MX has a private network that's peered with the VPC gateway, whichever type of gateway it is. So that virtual MX is now accessible from your WAN in underlay. Then what we do is we tell your Contrail controllers they have a new BGP peer, which happens to be your VMX gateway. So we fire up a BGP session between your on-prem Contrail and your in AWS VMX. At the same time, we connect the VMX interfaces to your bare metal networks. And inside these bare metal networks could be routers that connect to other bare metal networks with hundreds of AWS native services. Okay, so we've got underlay connectivity between the VMX and the Contrail controller using BGP. But what Contrail is going to let us do is to set root targets in the VRFs within your SDN. So let's say you have tenant red with 1,000 networks spread across your data centers. If we provision the same root target here and here for tenant red, then Contrail is going to stretch this VRF between the VMX and the on-premise Contrail controllers. And what that's going to let you do is dynamically have the SDN create tunnels of MPLS over GRE to give connectivity between the red networks and instances here and the red networks and services here, and the same goes for blue. And the size of this VMX instance in this video is the smallest possible. It has 4 interfaces, so we just have a couple of bare metal networks. But of course this will scale. If you use larger instances, you can have, say, 10 interfaces, of which you could use 7 or 8 towards the bare metal networks. We have an additional network here, which is public, coming into the VMX, and this is so that you can reach the VMX over internet for CLI access. Of course, in production, you might remove this interface. As well as scaling based on instance and interfaces, you could run lots of these. So you can have lots of small VMXs fired up into your VPCs and AWS, just providing underlay connectivity through your VPN gateway. And then you'll get multi-tenancy using BGP in the SDN as you are already. And then Contrail will dynamically create MPLS over UDP tunnels up to the VMX and break out to the bare metal networks. So that's really the idea of this use case. So at an application level, what does this get you? So let's just suppose that your developers have been deploying applications for an internet server into Kubernetes as pods, and these are sat in one or several of your on-premise data centers. And up in AWS, they're running a backend with EC2s holding a database, or perhaps they're running a backend with an S3 endpoint for storage, and they want the front-end applications on-prem to use these backend services in AWS. But of course, these are tenants. A tenant is like an environment or a world within the SDN. So it's routers, firewalls, networks, security policies, load balancers, all owned by that team of developers or that application. And they want to be able to stretch out to use these backend services without going through a 6-month program of development. And this setup that I'm showing you today will let you do that, and I'll show you how. So as with my previous videos, we're going to use a wiki for the steps. I'm going to share the wiki and the stacks at the end of the video, so there's no need to take notes, you can just watch. So what we're going to deploy in the stack is the AWS part of this use case. So I've got a couple of stacks that deploy a private network. This is the network that will then peer or route towards your existing VPC gateway. In my case, I'm using a VPN gateway, so I'm using IPsec into a VPC. But as I mentioned, Contrail's just looking for Ethernet connectivity. It'll work over any type of gateway or even just a straightforward AWS peer. The stack's then going to deploy the VMX. It's also, for convenience, going to deploy a public subnet with an elastic IP to internet, to public internet. And then it'll have secured access so that you can SSH into the instance and get the CLI. You'll see me doing that. And then I'm going to deploy 2 bare metal networks on the interfaces at the top of the VMX. The stack will also configure the VMX as an SDN gateway. So I'm not using Contrail Fabric here. I'm just automating the whole stack, so the single click gets you everything you're going to need in Contrail. I'm connecting routers to each bare metal network, and this is because I don't want these services, or in this case these EC2 instances in the VPC, to realize that they're being pulled into an SDN. I want them to DHCP in the usual fashion, pick up their IP and pick up a default network towards the gateway. I want things here to look as they looked before we arrived. But what I'm doing is injecting a route here to tell this route table to use this interface as its default out. So in essence, services deployed into this network will continue to hit the AWS gateway and then will get pushed through the VMX. And if this VMX is peered into a Contrail network, Contrail will then do the underlay, in this case the AWS bare metal networks here, and overlay networks down in your data centers. It'll route them together based on policy and forwarding. So as I said earlier, this is a small instance. You can change the instance flavor in the stack, and that will give you more interfaces. This particular instance allows 4 interfaces, so 2 bare metals, but there are much larger instances in AWS and much faster. I'm using the VMX in light mode, so you'll see it's fairly slow to come up. It's not particularly high performance in light mode. You'll get the same functionality, but it's very cheap to run. If you follow our documentation and scale up the cores and the memory, and then remove light mode from the stack and set performance mode, is going to be a lot faster. So this diagram shows you the lab setup that I'm running. So this is our stack that we're going to deploy. I already have a VPN gateway running. So AWS associates gateways with VPCs. So it's actually an inconvenience if the stack owns the VPC, because every time I delete the stack, I have to delete the gateway. And the gateway has config for an on-premise, in my case, IPsec in an SRX. So I provided 2 versions of the stack. One deploys the whole diagram at the top, and the second one, the brownfield that I'm going to use, just deploys inside an existing VPC. This is so I can leave the gateway connected even if the stack's being added or deleted. So I already have connectivity between my SRX and my native VPN gateway in AWS. I'm not going to run through how to do that in this video because AWS documentation is excellent. And if you want to use SRXs for VPN gateways, the configs are natively supported in AWS. You just need to click the GUI in the console and it will give you the config. My on-prem here is a Kubernetes sat in a data center in Amsterdam within Juniper. As I said, it could be any Contrail-enabled data center or data centers. It doesn't have to be Kubernetes. That's just for the purpose of this demo because it's what I already had up and running. So as with previous wikis, I'm offering you launch stacks, so you can click the button. This is the brown field, this is the green field. The only difference is whether I deploy the VPC or you've already deployed the VPC and I launch into it. So we're going to go for the brown field. So let's click the launch stack link in order to deploy the brownfield stack into my already provisioned VPC. So you can see I'm deploying into London, but as I've mentioned with the other stacks, you can change the region. So it's picking up the stack from S3. These are public. You can take the stacks, modify them, use them as examples, change them, do what you need to do. So if I click next, these are the parameters. So I think what we'll do is we'll deploy this stack, and whilst it's running, I'm going to talk you through what all of these parameters are. So for the brown field, we have to give it the VPC we want it to deploy into. For the green field, it creates the VPC. So if I go over to my console, I'm connected to London because this is my default region. As ever, I'd encourage you to deploy with the defaults first run. Get familiar with it and then change what you need to change. I already have a site-to-site VPN, Virtual Private Gateway, Customer Gateway. So I already have connectivity between my VPC and my on-prem data center, just using straightforward VPN gateway and SRX, could be direct connect. These, of course, can be shared. Contrail is an overlay, so it's running tunnels over the top to build these networks and services. You can still use these VPCs for other things. So you can see my VPN connection here, and I have 2 tunnels to my on-prem SRX. They're both up. If you're interested, if you download configuration, you can see that Juniper's already there. You select SRX and it gives you the config. It's very straightforward to bring these up. So the VPC I'm using for that VPN gateway is this one. So let's grab the ID. Let's paste that ID into the stack. Then I'm going to launch. There is one other field we need to set, and that's the SSH key. Oh, it's here. It's already set. So you see here, key name. This is the SSH key that you'll use for logging into the VMX and use for logging into the bare metal EC2 instances. I'll talk about those. So this will be a key that you've already dropped into AWS and you're using. So let's go next, next, create stack. So the stack itself is only going to take 4 or 5 minutes to deploy. However, the VMX, particularly in light mode, it's going to take another 15 minutes probably. So whilst it's deploying, let's take a look at those parameters and just walk through what they do. If you're deploying into your own environment, you will have to change some of these. So if I talk you through what they are, I think you'll find it useful. The wiki also explains. So availability zone, this is the country we're deploying into. This is London. So remember the diagram here, we have 2 bare metal networks, bare metal network 1 and 2. So here are the parameters for bare metal network 1 and 2. The root target, which I default to 1001, 1002, this is the root target you're going to put in your on-prem Contrail networks to stretch them up so that they can connect to the native services in AWS. This might not make a lot of sense now unless you're familiar with Contrail, but you'll certainly understand it at the end. So Contrail overlay networks, the MX needs to know where it expects overlay tunnels to come from. So this is the subnet. It can be a supernet. It just says I'm allowed to accept tunnels from this subnet. For underlay, so this is provisioned in predominantly into the security groups in AWS. It tells us who is allowed to do BGP and MPLS over GRE to us. So this will be a subnet that covers the underlay addresses of the Contrail controllers in your data center and of your worker nodes or compute nodes. Again, it can be a supernet. This is the ASN of your Contrail on-prem cluster. So you can see I have 3 BGP peer addresses. So I'm building this for HA. I'm bringing up 3 peers, 1 to each of the 3 Contrail controllers in your cluster. These are the addresses it expects to find the controllers. These are clearly going to have to change for your setup. If you're not running HA in Contrail, don't worry, just make them all the same value and it will work without HA. This is my SSH key for logging in. The private subnet, this is the subnet here that we're going to route via my VPN gateway. This is also the subnet you would peer into for a direct connect or a transit gateway. You can change all of these. FXP0 is the interface I use for CLI access to the VMX over internet. As I mentioned, in production you might decide to drop this one. As a convenience, it's nice to be able to log in and look around. SDN gateway instance type. So this is as small as the VMX can go, and it's very small. So I'm running in what's called light mode. You'll see it in the user data. If you make this a larger instance type, just follow the documentation for VMX, and you move it from light to performance mode, is going to get a lot faster. It's going to be more expensive and a lot more practical in a production network. Okay, these 4 SG subnets. So as a convenience, if you think that your data center's down here and it's trying to access the VMX interface here, you might have several subnets that need to come in, not just the Contrail underlay subnet that we provisioned above. So just as a convenience, I've given you the opportunity here to set additional subnets which I then inject into the security group. So I allow inbound traffic to the VMX from these subnets. The site name is used in tags for the services. If you were to deploy this stack several times into the same VPC or different VPCs, which of course you can do, you just change the tag. So 1, 2, 3, 4, 5 or something like that, or any other name you would like to use. User location. So this public access to the CLI, by default it's open to internet, but you do need an SSH key to access. What you can do, and I would recommend, is to change this subnet to the /32 address of your laptop. Then only you will be able to SSH into it. If you need to change it afterwards, you'll find that parameter in the security group for the private network. And we just populated the ID for the VPC. Okay, so that's all of the parameters. As I mentioned, the wiki also runs through the important ones. Let's go look at our instances. That stack would have finished pretty quickly, but the VMXs take quite a lot longer to come up, particularly in light mode. So if you look at the running instances, you'll see it's deployed 2 bare metals. There is a hook, by the way, in the stack. If you don't want the bare metals deployed, you can turn them off. There's a yes/no switch. Same for the networks. If you put no set in the bare metal subnets, the description tells you that, then I don't deploy them. You can attach them to your own networks. So my SDN gateway, as you see here, is initializing. So even after the stack's finished, give it another 10 or 15 minutes. When it's ready, you'll see a 2 of 2 checks passed here. Watch out, because for the first 60 seconds, AWS will show that. Then it will go initializing for 10-15 minutes. Then it will say pass. That's when it's up, and that's when we can connect to it. So I'm going to stop the video and we will return when our VMX is ready. So welcome back. I've given it, as you can see, the VMX instance is now up and running. Checks 2 of 2 passed. So we're ready to log in. You don't have to log in. Everything's pre-configured for you. You can just go ahead and run the remaining steps that we're going to do next, but I thought it might be nice just to take a look at the VMX, see how I configure it so you know how to customize and modify it. So as ever, if you look at the Cloudformation stack, in the output I give you hints on connectivity. So for example, I tell you the IP address that you're going to peer into with Contrail. We'll do this in a minute. And down the bottom I tell you the SSH, the public IP address, using the key that you specified, so it will be the private side of that SSH key. So let's connect. So I'm running over internet to pick up the CLI on the VMX. If I do a show configuration, you can see I've pre-configured it for you as an SDN gateway. So everything's in here to get you going, so there's no need to change it. But I think it will help you if I explain. But I do think it might help you if I show you how you would change it, particularly if you're familiar with Junos. So this is the stack that you clicked and downloaded. As I mentioned, this is accessible for you to play with and change. If you keep going down in the stack, you'll see here we're deploying an EC2 instance called SDN Gateway Instance. So this is our VMX. And if you go down past the network interfaces, if you were adding interfaces, there's your clue. Here's user data. So this is the Junos config that gets pushed into the VMX as it comes up. And if you look very carefully, you'll see that I'm building the config based on parameters that you specified in the stacks, or my defaults if you didn't specify them. And if you go down the bottom, you'll see I'm building a couple of routing instances. These are the routing instances I connect to the bare metal 1 and 2 networks using the route targets that we saw in the stack. That's bare metal 2, that's bare metal 1. So that's 1001, that's 1002. So you can see it's very easy to change this configuration and have this VMX doing something different. So back to the wiki. We're simply going to follow the steps. So we've already deployed the stack. You can see in the wiki there's the explanation of the parameters, which I gave you in the video. I've also provided the AWS CLI commands, an example to deploy the brownfield and greenfield, because of course some of you perhaps prefer to use AWS CLI to the GUI. I certainly do. So now we're down to the configuration. There isn't much to configure because the stack's done it for you. But the first thing it's telling us to do is to set route propagation in the private route table. So let's go and show you what this is. So if I go to the VPC, if I go to route tables, you'll see my stack has provisioned a few route tables. These are the bare metal route tables, and there's a public route table for internet and a private, and this is the one that you're going to come through from your on-prem through your VPC gateway or your direct connect gateway. Route tables, when they're provisioned, do not have BGP enabled. However, it's normal in AWS to run BGP between AWS's gateways, in this case a VPN gateway, and your on-prem. You don't have to run BGP, you can just use static routes as well, that will work fine. But BGP is a nice convenience because it tracks changes to subnets here. All it's going to advertise from AWS is what's called the VPC subnet. So it's just basically going to advertise one route down. Well, by default, route tables don't have BGP enabled. It's a parameter against your gateway. So even though it looks like it's in a route table, if you go look at the API or the CLI, it's actually a virtual private gateway or a direct connect or a transit gateway parameter. So it's disabled by default, you just need to go into the private route table that I spawned up for you, click on the route propagation, edit route, and tell it please advertise and show the routes via BGP for the gateway. And immediately you're going to see routes appearing from your on-prem. And one of these routes is the Contrail underlay route, the one that you provisioned in the stack that I then used to tell the MX this subnet is allowed to do MPLS towards you. But immediately what we have now is connectivity between the VMX private network interface here and my data center on-prem using BGP over this connection. Same goes for direct connect, same goes for transit gateway, they're all the same. So back to the wiki, we've done that step, we've enabled route propagation. This is the only modification we need to make in AWS. So the next step in our wiki is to add the BGP peer into your Contrail controller. So Contrail may have reachability to the VMX on the private interface, but you haven't actually told it peer it as a gateway. So this is my on-premise Contrail GUI. We're just going to follow the wiki. So you can see I've already got quite a lot of BGP peers, other controllers, other MXs doing various things. And I'm just going to add a BGP peer following the parameters that I've shown here in the wiki. So router type, BGP router. Hostname is the hostname that AWS gives it. Vendor ID is Juniper. Watch for the uppercase J. The IP address, so this is the interface on the AWS private network. By default, this will also become its router ID. I'm using the default AS 64512. You can change it if you want. For address families, INET EVPN, INET VPN route target. So there you go, there's our 4 address families. And then for BGP peers, associate peers, and I'm going to associate the 3 controllers because I'm running an HA, and that's it. Let's save. So what I'm suggesting here is check the status, and I'm giving you 2 ways to do it. So I'm telling you can check it in Contrail, which indeed you can. Let's go check it in the MX. Show BGP summary. So you can see we have 3 BGP peers between our VMX that we logged into here and our 3 controller nodes, and they're all established. So adding the fabric subnet to the Contrail controller. So let me show you that. I've actually already done it, but in global config system, we maintain on Contrail a list of the subnets that are allowed to talk on the fabric. So we're allowed to do MPLS over GRE in our case. So in here, as the wiki shows you, I'm specifying or adding the AWS private subnet. So I'm telling it that it's allowed to talk to interfaces on this subnet here. I've already added that subnet. Okay, so at this point, we just want to stretch some networks. So let me show you my lab setup. So down here in Kubernetes, I've fired up a couple of pods. So let me show you that. So again, this could be OpenStack VMs, VMware VMs, OpenShift pods, anything that's talking in Contrail overlay. I just happen to be using Kubernetes. Let me do a kubectl get pods. This will show me any pods I'm running in what's called the default namespace. And I have 1 pod running. If I do -o wide, you'll see where it's running. It's running in an on-prem data center called DC Compute 1 in my Amsterdam lab. I'll use a second screen. This screen's in exactly the same controller, controller 1. I also have a namespace configured. So if you're not working in Kubernetes, this might not mean much, but if you are working in Kubernetes, it's going to be of interest. So I provisioned a namespace called deposits. This is like a world of routers, firewalls, switches, and load balancers, and Kubernetes uses these a lot. This particular namespace is an isolated namespace. So by default, it can't talk to anybody or anything. And what we'll do is we'll stretch the default namespace here, the pod in here, we'll stretch that out to bare metal 1, which is here, and we'll stretch the isolated namespace out to any services running in bare metal 2. So the Git tells us how to do that, because I want to give you an example start to finish. So the way that Kubernetes is using these networks, but if I go to my Contrail Networks, I'm in the default namespace here. I'm in the default Kubernetes namespace. I have a network. So if you're not familiar with Kubernetes, just think network. In OpenStack, when you create a network, this is where it appears. Same rules apply. In VMware, when you create a network, this is where it appears. Same rules apply. But I'm going to select the network that I know that my pods are in. I'm going to edit the network, and all I'm going to do is add a root target. You can see I should have given you the commands here. There you go. 64512, and it was 1001, right? 1001, and this is the target for bare metal 1 in the MX. I'll save it, and then I'm going to go to my isolated namespace. So namespaces appear as projects. So there's my deposits, and there's the network that pod is sat inside. And I'm going to go root targets, and I'm going to give that the root target for the second bare metal 2 network. So that's all you have to do to stretch networks. Just give them a root target that lines up with the root targets that I provisioned in the VMX, which come from the stack parameters. So you can change them. So at this point, these networks are stretched. So in Kubernetes, the easy way to see that is to jump inside the pods. Let me jump inside. That's the default namespace pod, and let me jump inside the isolated namespace pod. And now if we go back to AWS, if we look at those instances that we deployed in the stack, remember I told you that by default I'll deploy a couple of bare metal instances just so you have something to ping unless you turn those off. So this one sits in bare metal 1, and this sits in 2. So this is in bare metal 1, and this is the IP it got. It's just doing DHCP in the subnet. So if I go back here and ping, there you go. I'm reaching bare metal 1, and if I go over here and I ping, I'm reaching bare metal 2. So if we look at the diagram and think about what's going on there, because it's probably very confusing at this point, we're in a couple of pods down here in separate namespaces, the separate projects inside Contrail. And they're obviously completely isolated from each other. That's the natural state of Contrail. But what we've just done is we've simply said, the first pod here, stretch it to root target 1001. And that's enough for the VMX and the Contrail controllers to share roots, and for the pod here in the default domain to get access to whatever's sat in bare metal 1. And what we just pinged is EC2 instance on bare metal 1. And then we have this second isolated namespace, which can't talk to anybody or anything because that's its natural state. And we just said it has a root target 1002, and automatically that had Contrail advertise the route between 1002 here and the 1002 VRF that you're using down in your data centers. And of course that could be stretched on to other data centers. We're not using underlay. This is multi-tenancy. We're creating flows between the compute node that owns the pods, but we're creating tunnels between the vRouters down here, where the pods or VMs are sat, and the VMX up here, and that's done dynamically. You're not saying anything other than I want to stretch the network. And of course the proof would be to look for MPLS traffic, right? So what I can do is I can just go into compute 1, which is where these pods are sat. I can say, show me any GRE, MPLS over GRE traffic. And there you go. There's the MPLS over GRE flows for the 2 pods that are pinging up into AWS. And your Contrail policies are going to decide, your security policies are going to decide what sort of traffic can flow. I currently have policies in here that says anything at all. So thanks for watching what is a fairly interesting use case, which probably has a million purposes we haven't thought of yet. So have a play. Let me know if you think of other things to do with it.